functions. So you just cannot, unless the property is very simple, obviously, but you just cannot just analyze one function. You have to analyze what happened when the pointer is passed to other function, etc. So in those particular properties, we have to use the double checking. So for 1 line of code, sometimes we go up to 30 hours. But, I mean, when we can avoid to do that, we do, but sometimes it's just unavoidable. So, example of a Java connotation, I said it already, like when you have, like every time you have an API, it's very simple. You can like take like a separate file, you call it like mynotations.h or something, and then you just like write require start equals 0, prototype of the function. Whenever the function is called, it's going to check if this annotation, this precondition is always true. So you don't need to annotate all the code. You just need to do separate file and say, oh, this API, I want this particular parameter to be like respecting this particular constraint. So the annotations are very small. We don't need to write like a big annotations file. Like it's really, really straightforward. And as I said, just doing that on like a couple of dozens of API of memory allocation on the Windows kernel. So we have maybe like 50 lines of annotations or so. We do that, and we filter 98%, like, depends on each component, sometimes it varies on 1%, you know, but like, it filters out like a huge part of the space, and then we just remain very few wanting to check manually. Or you could use global analysis and have a perfect result, because what you can improve locally, you can prove it if you had analyzed the colors and things like that. But it's just not worth to do it for such simple properties, and like zero rotation is an extremely simple property. This approach can also find complex bugs. For example, we have three components of the Windows kernel. One is the server driver. One is the I/O manager. So for those of you who are not aware, in the Windows kernel you have a component called I/O manager, and whenever drivers interact together, they pass through the I/O manager. They construct a structure called IRP, interruption request, and they construct this structure and they pass it to the I/O manager that is going to forward it to the driver that is supposed to answer the request. So you have like remotely reachable drivers in the Windows kernel that are going to talk to the I/O manager, and then the I/O manager talks to local drivers, say file system drivers or any kind of other drivers. So those bugs are really hard to find, because sometimes you have like, oh, I do a request, and then in the I/O manager, the tainted, the user supplied size can be 0. There is an alloc 0 that happens in the I/O manager, and then it calls another driver where the dereference happens. So if this is 1 million line of code, 1 million line of code, 1 million line of code, obviously you have to analyze multiple millions of lines of code, and this is not straightforward. So what we do is we try to understand the code manually. We know, oh, if this particular interface API takes this particular parameter, this very bad thing is going to happen behind. So we don't need to analyze like 3 million lines of code. We actually put the annotation on the interface API that is used to communicate between components. So by enforcing preconditions or interface functions like that, we can actually find bugs without having to deal with the whole component. We just analyze one component in particular, and we make sure that the interface is actually called properly. I'm finished with Havoc, so if you have any additional questions, let me know. What I'm going to talk about now is the last part of the presentation, is a generalization of the allocation. Sometimes you have allocation that happens on, say, size plus 1. So size can be 0, but size plus 1 is not 0 anymore. So you cannot find this with what I just presented, because if you do require size different than 0, size plus 1 will not be 0. Size plus 1 is going to be 1 at least. So the tool doesn't work for such cases. But still, in some particular circumstances, you can have bugs where the size is tainted, is untrusted, and it can be 0, and some padding is added. And so there is no 0 allocation, but there is like in the neighborhood of 0, an allocation happens. Unfortunately, we cannot see the example very well, but this is exactly what I just said. You have this remote heap overflow that we have fixed now. It's in some other projects. It's not a kernel bug, it's a userland bug. So you read an integer from the network, and that integer you add it to, and then you allocate it. So basically you have a 2-byte allocation. It's not a 0 allocation, it's 2-byte allocation, and the value of the parameter is not 0, it's 2. So require size different than 0 is true, no problem, no warning.